This is the last video I am planning on doing on new material for this year. That doesn't mean that that's where we normally get to by the end of the school year. There's a lot that we missed this year, so I encourage you to go through the rest of the PowerPoint and kind of look at it. A lot of it's self-explanatory. If you just look at it, I believe you guys are smart enough to figure it out, but this is the last video I'm going to do. So the last thing we have is the stoichiometry of gases. So we use pivnert, and so now if we know moles, that allows us to do stoichiometry, figure out how much we're going to make, how much we need to start, so on and so forth, like we did in the stoichiometry unit. So if the reaction does not occur at STP, you use the ideal gas law to calculate the moles. So essentially what we're saying is you can put in any pressure and volume or temperature with pivnert, and so whenever you have a gas at certain conditions and you need to figure out moles, always use pivnert. Here's the sort of the map for you. Typically you take your grams and convert it to moles, or your particles and all that sort of stuff. Like I said, if it's at STP, you know there's 22.4 liters of the gas in 1 mole, but if it's not, you have to use pivnert. So you can use pivnert to solve for N over there on the left, and then that's going to give you the moles of that gas. Well, then using your balanced equation, the don't overdo it step would be right here, and then you get an amount of whatever it is you're looking for, and if you need to solve for volume of the gas or whatnot, you can go ahead and just use that little section. So this is the type of problem you'll get. What volume of carbon dioxide forms from 5.25 grams of calcium carbonate at 103 kilopascals and 25 degrees Celsius. So looking at this, first thing you need to do is convert 5.25 grams of calcium carbonate into moles. So right here, this is your balanced equation. Notice you got 3 oxygens, a carbon, and a calcium. So convert that gram amount into moles. Okay, and then you can go ahead and do your stoichiometry conversion. So this right here is the don't overdo it step. Since it's a 1-to-1 ratio, you got that conversion right there. So this is getting it to moles right here, and then this is the don't overdo it right here. After you get the moles of carbon dioxide, then you plug that into pivnert. So you're looking for volume of carbon dioxide at 103 kilopascals and 25 degrees Celsius. So you got to convert that into Kelvin, and you're going to have to use the kilopascal value for R. So when we do this, this is what we get. P is 103 kilopascals. You have the matching R value to go with kilopascals. Convert this to Kelvin, and then you plug in your mole amount, and then just solve for V. You should get 1.26 liters. Another type of problem would be how many grams of aluminum oxide are formed from 15 liters of oxygen. So notice this would typically be a limiting reactant problem, but since they didn't give you an aluminum amount, you don't have to worry about it. So you just take the amount of oxygen they give you and convert it over to aluminum oxide. So first thing you do, take the pressure, the volume of oxygen, the temperature, and the R value to go with the kilopascals, and solve for N. So when you solve for N, you get 0.597 moles of oxygen. Now you're going to don't overdo it. So we do have oxygen, we don't have aluminum oxide, so the don't overdo it step is going to be 2/3. So we got our moles of oxygen, 2 moles of aluminum oxide for 3 moles of oxygen, and then 1 mole of aluminum oxide is this many grams, because they don't want just moles of aluminum oxide, they want grams. So you get the molar mass, put it on top, and you should get 40.6 grams of aluminum oxide. So those are the toughest type of problems you're going to do this year, and so I hope it makes sense. Be sure to let me know if you have any questions.